Hi, everyone. We're just letting some folks join in here over the next 30 seconds to a minute or so. Welcome, welcome. I think we'll go ahead and get started with some intros and housekeeping and let folks roll in as we do so. If you're here to learn about the Groundwater Accounting Platform in California, you have come to the right place. My name is Noah Brujes. I'm a senior analyst with the Environmental Defense Fund, and I'm here presenting with 3 fellow platform team members: Hannah Ake with the California Water Data Consortium, Andy Loveseth with Environmental Science Associates, and Jim Schneider with Olsson. And we'll take turns kind of sharing some aspects of the platform with you today. Just a little bit of housekeeping as we roll in and before we get started in earnest here. We'll be recording this webinar and we'll post it on the California Water Data Consortium's YouTube site. And we'll share a link for that YouTube site at the very end. We have enabled closed captioning for this presentation, so you're welcome to press the button at the bottom of this Zoom screen for closed captions. And if you don't see a captions button, check under the more, the 3 dots with the more. And then another note is that the chat is disabled for this webinar, so we invite you to drop any questions into the Q&A feature throughout the presentation. And you can comment on and upvote questions from others. And we'll be working to address those questions as we go along. And then we'll also have time at the end for remaining questions where you can use the raise hand button to raise your hand virtually, and then you can come off mute and ask questions that way. And again, if you don't see a raised hand button, look under more. All right, so this is just a little orientation to what we'll be talking about today. Some of you are familiar with the platform and some are not. So we will share the vision for the Groundwater Accounting Platform and provide a bit of project background first. This project has and continues to advance in collaboration with a lot of partners and advisory groups. So I'll just kind of share a little overview of that, the project team and some of our venues for participation. And then Andy will walk through a tour of the platform and Jim will demo the scenario planner functionality. And then at the end, Hannah will field questions and comments, and we'll leave that opportunity maybe 10 or 15 minutes at the very end. So the vision for this project is to provide local agencies with high quality, consistent data and open source tools necessary to help them better manage water resources during drought and flooding, and to support them in transitioning to long-term groundwater sustainability under SGMA. The Department of Water Resources and the U.S. Bureau of Reclamation are funding this project, and we're working to further develop and scale an open source groundwater accounting platform that was originally developed by EDF and Sitka, which is now ESA, in partnership with Rosedale Rio Bravo Water Storage District. We see this as a great opportunity to advance the work that's already underway and ensure that, as required under SGMA, there's consistency in approaches across subbasins and also ideally between subbasins. So our goal is to ensure that this effort is useful not only to landowners, water managers, and GSAs, but to the state at large. Again, I know some of you are familiar and some aren't, so to orient you a bit, on the work that's been done to date, I wanted to provide some background as a jumping off point. As I just kind of briefly alluded to, the platform was originally developed beginning in 2018 with Rosedale Rio Bravo Water Storage District. Rosedale was especially really interested in a tool like this because they're a large agency located in Kern County in the San Joaquin Valley, and were designated as a critically overdrafted basin under SGMA. And the leadership there recognized that having a water accounting tool that could be used to set allocations and then communicate those directly with landowners was going to be imperative to achieving groundwater sustainability under SGMA. So to solicit feedback during the initial platform iteration, we hosted a series of landowner workshops, and there it became clear that landowners wanted not only something effective, but also user-friendly and straightforward. So we've really tried to keep that in mind as we work to expand the platform beyond Rosedale. The open source nature and state funding mean that new users can leverage all the work previously done and will benefit from future improvements as well, keeping costs low compared to starting from scratch. So this next phase of work, which is being undertaken with financial support from the Department of Water Resources and Bureau of Reclamation, is well underway. And we're excited to show you how the platform has evolved to be more scalable and more accessible with a lot of functionalities, ultimately making it more useful for a variety of GSAs. Here I've listed the project team, including the California Water Data Consortium, Environmental Defense Fund, Environmental Science Associates, who are responsible for the software technical development of the tool, and Olsson, who developed the modeling and scenario planning. And here I have the list of pilot partners who were originally participating in development, contributing to the development of the platform. So we're grateful to the support of these outstanding partners who have been joining monthly calls to help shape the development of the tool. And we also have a longer list of individuals and organizations who have been contributing to quarterly advisory group meetings. You can find that full list under our website, in our website under acknowledgements. But today we're demoing a range of the things our platform can do. And each agency on this page will have its own policies and subsets and combinations of these functionalities. So it's not to say that every agency here has every functionality that we're talking about. Okay, so to orient those of you who are new here, the platform has three main components shown as three differently colored rows in this figure. So the first are the data being used to estimate water use. And you can see these at the top as inputs to groundwater accounting. In its first iteration, the platform only used the satellite product OpenET to estimate water use. But we now have the functionality to integrate additional water use estimates from meter data as well as other satellite data to ensure that the accounting tool is useful to a broad range of GSAs and flexible to specific geographies. The meter data or other data integrated into the platform are password protected and can only be viewed by landowners or district managers. The second component is the integration water budgets, which you can see at the bottom as outputs of groundwater accounting. These serve as the basis for water allocations, resource management decisions, and the longer-term basis for water trading if agencies or districts decide to go in that direction. And the final component seen in the middle row is the expansion of platform functionalities to include decision support tools, which will ultimately tie into the expansion of scenario planning and visualization functionalities within the groundwater accounting platform. To support these components and scaling process, we're working with Olsson, an engineering firm based in Nebraska, on integration of their groundwater evaluation toolbox, better known as GET. GET is a cloud-based visualization tool that uses an agency or district's existing groundwater flow models to enable water managers to run and evaluate the effects of management scenarios like pumping or recharge in near real time and visualize those impacts. The last thing that's helpful to know before we dive deep into the tour and the fun part is that there are three user experiences within the platform. The first is a landowner or operator who can log in and see their water budget for their parcels in one or more geographies. Excuse me. That would be like a GSA or a water district. The second is a water manager who can set up rules for their geography and administer roll-up water budgets. And the third is a platform administrator who has access to platform operations and configuration across all geographies. So with that, I will hand the reins and the screen sharing to Andy with Environmental Science Associates.
Thank you, Noah. I'm going to share my screen here. So the platform is located here at groundwateraccounting.org. like Noah said, there's a couple of different user types. I'm going to dive into two of them, one being our landowners, and then second being our water managers. So I'm going to sign in. I have two accounts, one for a landowner, one for a water manager. So I'm going to hopefully sign in here. There we go. As a landowner. And when I come to the screen as a landowner, I'm shown my data. My account has been configured a bit already, and we can see here that I have an account in the demo geography. We have a demo geography so that we don't have to showcase real data in situations like this. The demo geography has a parcel layer made up of fake parcel boundaries overlaid over the area that is Rosedale Rio Bravo. So all of the data you'll see here in the demo is of not real parcels, and so that anonymizes the water use for that area. So we can see here I have water accounts in the demo geography. I have some parcels and I have a well. And I want to take us to the water dashboard. And this is where users in the platform, landowners in the platform can see their data and only their data. They can't see other people's data. No one else can see their data. So their water dashboard is different from other people's water dashboard. And so when you click on Water Dashboard, you are met by your water accounts. I have one water account right now, and my water account is called Barnyard Bonanza. It has 4 parcels in it. I can see it here on the map. I can hover over it, and you can see these shapes. There's 4 parcels in here. You can see the shapes here when I hover over it, and I can click and see it, and I can click View Water Account. When I click View Water Account, I come to the water budget page. And this is meant to be an overview and more or less the real-time snapshot of your water account status of use and supply. First and foremost, you see that in our demo geography, this water account has been given 3 acre-feet per acre for the year 2023. That's their total supply. We see that from the usage, they used 2.36 acre-feet per acre, and they had a positive balance of 0.64. And so this water account is in good standing. It has a positive supply number. As we go down, we can see the cumulative water use over time over the last year. In 2023, each month, we can see the amount of usage that this account had. The demo geography is using OpenET, satellite-based technology that does remote sensing of ET. And so we're getting monthly installments of usage from OpenAT, and we can see that here on the cumulative use chart. We can also toggle to a monthly view, and we can view that the blue is the current year and the gray is the average of past years. And so we can compare this year to all previous years in a monthly view. We have a usage meter here below. You can see that in 2023, this water account used nearly 80% of its supplied water. And then you can see the make of water. And in the water account, water managers give you credits or water supply types. And this is the makeup of the water supply types. We can see that there's what we're calling project water for this water account. It makes up most of its supply, and there's a little bit of what they're calling native yield. And so this page gives us a snapshot of this water account, and a water account is just the collection of parcels of this water account's usage for year 2023. You can go back in time and look at other years. You can also change the units from acre-feet per acre to just acre-feet. And so you can just see the total usage there, and it updates all the charts and figures as well. So this is one of the main views that a landowner or a grower would see for their water account. Another one is what we're calling the account activity page within your water account. We like to think about this as similar to online banking. You have debits and credits, and you have a balance sheet. And so this is the balance sheet view. For all of the debits, all of the usage. You can see that we have line items on a per month basis of usage estimates of water use over the month for each of the APNs in the water account. So you can see each of those here on the ledger. And additionally, at the start of the year, we were giving credits, and these are the supplies added at the start on a per APN basis. So we have a really robust view of what's coming in and what's going out in terms of water on this account. If you wanted to see this in really raw data form, you can toggle to all transactions here, and you have a grid of all the water, and you can download this to CSV and import it into your spreadsheet software of choice. Last thing I want to showcase here for the landowners is allocation plans. Within the platform, managers can configure a chart, an illustration, a figure of allocation plans into the future, what water and what the rules of the water credits you have will look like into the future. And so what we have here is this essentially a Gantt looking chart of what the credits look like in the future for this water account, which is in a particular zone. It's in zone 3, and I'll talk about zones a little bit. But for project water, which is one of our supply types, a grower can see into the future the allocation plan for their water account in their geography. So this is meant to be an illustrative figure. This isn't meant to be what the hard-coded plan in the technology is, but this gives a grower an idea of like, oh, this is what it's going to look like in the future for my water supplies. So that's the water accounts portion of the water dashboard. I do want to showcase the parcels. So for each individual parcel that you have ownership of in the water dashboard, you can click on those individually and then see a greater detail on a per parcel basis. And so we get this nice page where we have an overview, we got a nice map, we have overview information, but then we also dive in here and we see the water measurements on this parcel. And so this is on a per parcel basis. We can see the OpenET's ET measurements. We can see their precipitation measurements. And then for the purposes of the water, for this demo geography that we've set up, we have a consumptive use number as well, which is simply the ET minus the precipitation. For any geography, they will have the ability to configure what that equation looks like. Ours is pretty simple. It's one number minus another, but you can imagine a lot of effective precip calculations being set by policy, by GSAs, and that will be configurable within the platform. So landowners have the ability to see all this data. It's showing 2 years worth of data right now, but I can go back in time and show you back to when the data starts in 2016, all the data that we have all the ET data back to 2016. We have precipitation back through 2019. And then additionally, we're showing the allocation plan that this parcel has for its water account. And then you can also download all the data that we saw in the parcel ledger here for this particular parcel. So all of your data is portable off the platform. You can find it and download it into a spreadsheet. Last thing I want to showcase, I'm going to go to my profile because this is where this is now. The platform is now a well registration portal as well. GSAs can who have policies around all the wells in their GSA being registered can now do that in the Groundwater Accounting Platform. And I just wanted to showcase, I started one earlier today, and I want to show you some of the features of that. So by policy, oh, that's not the edit. I will go back here and continue editing this. You can now register a well on your that belongs to you in your parcels and in your water account. So here I am. I've selected the parcel that I want to register a well for. I can hit save and continue. And now I need to map it. Either I can find it from a list of reference wells we've imported from state data, or I need to plot it myself. I don't see a reference well here, so I'm going to hit plot your well. I'm just going to hover over it, and I'm going to click there and then drop a point, and hit save and continue. It's going to ask me to confirm my location. Is that exactly right? The map zoomed in a little bit more. Maybe I want to just move it right to exactly where it is so we can get great data as to where this well is. And I hit save and continue. And then last thing we want to know is which other parcels, including the one that it's on, does this well irrigate? And so the yellow ones are the ones that are clicked to irrigate. I can just click on the map and add another one, and I'll add this one across the road as well. So we have three parcels that this irrigates, and I hit save and continue. Now I've already pre-filled out all the sort of boring information that one needs to fill out when you're filling out forms, but geographies will be able to configure what these forms are in the future and ask users the questions they want to ask when they're asking folks to register wells. And so I can save and continue. I don't want to attach any files. I'm going to acknowledge that I'm done and hit submit. And then I have a well registration that's submitted. And so I want to emphasize that the users in the platform have access to their data, their water accounts, their parcels, and their wells. There's workflows for claiming water accounts, for registering wells, for looking up allocation info, claiming new water accounts from multiple geographies at once if I wanted to. So as a front-end user, as a landowner in the platform, I have access to my data, and we think that it's a pretty good experience navigating around and looking at it. So I want to turn over, I'm going to sign out, and then I'm going to sign into my admin account. And we're going to show you some of the manager features. You'll notice as a manager here, and I have a new black bar up at the top of the screen. I've got some handy dandy links for me. And I'm going to click on manager tools. And this is the prototype of our activity center with some really important links for managers. The first thing I want to click on here and I want to showcase to you is the geography statistics. We showed you the water budget on a water account. Well, now this is the equivalent of that on a geography scale. We have the total, you can see the big numbers here if I switch over to acre feet. We have the total usage and the total supply for the entire geography represented here. And we can see both in the cumulative view and in the monthly view, the same kinds of statistics and views that we saw on a per water count basis, but this is all water accounts. So we can see what we're supplying in credits and what share for project water and native yield here. It looks like for the entire geography, we used about 75% of the water that was supplied. Most importantly, potentially, is I want to show you this water account budgets. This is a data dense view of every single water account in this demo geography. And so if we come over here, we can see line by line for each water account, the total usage and the current available. And the current available, if I sort this, we can see the negative numbers are the accounts that have gone over their supplied budget. But we can, if we scroll down, we can see there's lots of accounts in the positive as well. So managers can download this data to a CSV and do any analysis they want offsite. But this is the sort of potentially one of the more important views for managers on the platform, where they can see the status of all their water accounts and who's in the red and who's in the black. I want to go back to manager tools. Just like in the water dashboard, we have three main entities that the platform deals with: water accounts, parcels, and wells. And as a manager, you have essentially two different but two important tasks. The first is sort of the setup and configuration of the platform to your policies and needs. And the second is the more day-to-day operation of the platform, managing water accounts and parcels and wells. Let's talk about configuring and setting up the platform. The platform is meant to be scalable and configurable. And we recognize that not all GSAs have the same policies and not all GSAs are alike. And so they need optionality and the ability to configure the platform as they see fit. And so I want to come over to this configuration menu here. And I'm not going to dive into each of these, but I just want to showcase that we have lots of different configurations that our water managers can turn on and off. And within those, there's various options for them to choose from. For instance, in terms of water usage, the demo geography uses OpenET, but we support all manner of remote telemetry sensed data as well as metered data in the platform. We are data agnostic in that way. And so I want to just showcase that there are lots of different configurations to this platform. There's not one size fits all. And so we have this configuration menu, and when you're setting up the platform, you can set it up to your needs and work with our team to set up precisely what you need. From the day-to-day perspective, you'll likely be dealing with landowners and growers who have various needs. And so, you know, they need access to their parcels, or they want their water account to be configured this way or that way, or they need to set up a well registration, whatever it is. And so we've built tools for our water managers to deal with that. I want to dive into to showcase some of the water account tools here. If I come into water accounts and I go to my list of water accounts, this is the same list you saw in the water budget table. We recognize that sometimes the data that our geographies, our GSAs get from the tax assessor or whoever they're getting it from isn't perfect. And it doesn't represent what they want to showcase in the platform. And so we need the ability to, when we ingest it, we need the ability to edit it afterwards. And so I want to showcase a couple of things. So for my water account that I had for my user, the Barnyard Bonanza water account, I want to showcase that we have a couple options here. First, update parcels. You may discover that these 4 parcels aren't the ones I want. I might want to remove or add parcels to this. And so we've built in tools that allow you to remove a parcel. You can see it turned red there. And I have to select an effective year as to when this happened, and I can do that here. And so we have the ability to, we discovered that land management within the platform is a big deal. And so we've built tools that allow us to easily manage our water accounts and allow our water managers to provide service to their landowners in their geography. Additionally, you may want to update the information about the account, the name of the account, who's the contact and the contact address, any notes you want to give to that water account. You can do that here as well. And then finally, depending on what happens in the import of data, you might want to just merge 2 accounts together. So if I wanted to merge 2 accounts together, I have 4 parcels here and 3 parcels here. This is showing me a preview of what a potential merged account of Barnyard Bonanza and Apple Bottom Farms looks like. And so as a water manager, I have the ability to really mold and shape the data as I see fit. Let's see, what else? As a water manager, I might want to set up different kinds of zones. And I definitely need to set up zones if I'm going to have an allocation. And so I want to showcase 2 things. I want to showcase zones. That's over here in the geography configuration. Here we have 2 zones in the geography. We have management zones and geography status. I'm going to showcase management zones. If I hit edit here, we can name our zones, give them descriptions, and give them colors so they show up differently on the map. So these are the zones I've set up. And then if I go into manager tools, I can assign parcels to zones. I can select a group from management zones, and I can upload a CSV assigning parcels specific zone names. And so that can be done here. And after I've set up my zones, I can then set up my allocation plans. And here we have a configurable builder for those figures I was showing you. This is showing 3 acre-feet per acre of water in 2022 project water. If I wanted to come here and make that 3.25, and it has, 4 years of carryover with a depreciation rate of 0.5%, I can save that, and then it's showcasing that here. So I just wanted to showcase that we have these user-friendly tools on the platform that allow us to update and configure the platform, as well as manage it on a day-to-day basis. I think that's good for now. I think I want to move it over to Jim, if you're ready, Jim. And I'm sure there'll be questions at the end. I think I want to leave questions at the end, but I think that's a good overview of the manager tool, as well as the landowner tools. So Jim, are you about ready?
All set.
All right.
I can see on the screen here. Okay, so if the scenario planning module is turned on, and you're a user that logs in, you'll see another menu option up here labeled Scenario Planner. And as Noah mentioned earlier, this is an integration with a pre-existing platform called the Groundwater Evaluation Toolbox, or GET, which we at Olsson developed. And it by its original design, it was built to automate the use of ModFlow models. ModFlow is a pretty standard modeling code that was developed by the U.S. Geological Survey. Pretty standard across the country and, in fact, the world. However, when we started looking at applying GET in California, we realized that the Department of Water Resources has developed their own type of modeling software called the Integrated Water Flow Model, or IWFM. So one of the tasks that we've undertaken in the last year and a half or so is we added functionality within GET so that it also can manipulate IWFM models and potentially add other model types in the future. So it's become it's kind of changed from being very particular to ModFlow to being capable of a number of different modeling softwares that might be of interest or have been applied in your area. Here you can see the 3 models that we have set up. This is actually mislabeled. We're working on the YOLO subbasin, YOLO Sustainable Groundwater Agency Water Resources model, and it's a ModFlow model. We've also got a version of this C2V Sim fine grid model that was customized for Kern County, and the Merced Water Resources model. So, over time we can add as many models as users would like to be able to see and utilize within the system. And then the real where the rubber hits the road is with the scenario runs and providing the ability for the platform to send instructions via application programming interface, or API, send instructions to GET on the type of modeling scenario that we would like it to complete. And I'll demo that in just a second here. We've got a kind of prototype of that set up. And then the platform is able to, at any time, reach out to GET and say, hey, where are you at on that scenario I asked you to run? And it'll send back the current status of the run. So, but to start with, let's go to the scenario runs. So if we click on this icon here, we see the latest runs that have been completed, and then a grid view of a number of example runs that we've completed as we've been putting the finishing touches on the initial functionality. I'm going to I'll go back to the models so I can demo a new scenario. And right now we have two scenarios. One's called add a well. It does just what it says, and the other one is recharge. Also doing just what it says. You can drop pins onto the map and under add a well, add new pumping wells and new observation locations. And if you select recharge, you can do the same for one or more recharge sites and points of interest for groundwater model output. So I'm going to add a well and going to give this semi-official sounding name for a scenario we're running for a new well permit. And then this is the blue area shows the outline of the model region. And by simply clicking that you would like to add a well, perhaps zooming in to find out where exactly that's going to go. And then simply giving it an estimate of the monthly extraction rate. In Get has quite a few additional features that we've developed outside of the platform that haven't been brought in yet. But as an example, one thing that we can do and could do in the platform is instead of an average pumping rate, specify a pumping schedule and get the results from that. So it's going to return results for us in terms of the water level change at that location where the new well is. We can also add what we're calling observation points. They don't have to coincide with the location of actual observation wells, but they could. And we can add one or more of those. And when we're done setting it up, simply run the scenario. So right now it's sending the instructions to the Get API. It'd take just a second. And if we wanted to view that run, we see that it's been created in Get. And anytime we want to check the status, that just that quickly, it went from created to being queued up. So it's now in the queue, getting ready to add that well to the model, run the model, pull the information out of the model for the location of the well and the observation points. And once the status is completed, it would send that information back. And so to show what that looks like real quick for now, I'm going to hop over to this one. Here we have a very similar simulation where we've added a well, a pumping well, and two observation wells. And we're just kind of scratching the surface on what we're showing here for output. And we're really still at the phase where we're simply showing output from the model. Right now, we're in the process of trying to transition the accounting platform output to being more than just the results of a model, but to actually provide actionable intelligence to whoever's running the scenarios. So that, for example, we might also be showing the number of domestic wells known to be in this location, and that might influence the decision combined with the amount of drawdown and so we may have policy considerations built into the platform where it gives like a green, yellow, red for good, maybe okay, and bad. So anyway, stay tuned for that. We've done probably the hardest part, although we in terms of getting the systems connected, although we know it's going to be a little bit of a challenge. Creating building this out so that it's more informative to the water manager when they utilize the scenario planner. So with that, I will stop sharing, and I believe I pass it over to Hannah to feed the group questions.
Yeah, thanks everyone. Thanks for being so active in the Q&A. I really appreciate it. I'll definitely defer to my other panelists here to help me answer some of these questions as we move through. And since we got so many questions, I really apologize if we're not able to get to all of them, but please email the team. We'll put up a slide in a bit with our contact information so that we can make sure to get your questions answered. The first question I think is a really good one, just about what is the platform essentially at its core. And really it's meant to be structured like a checking account. So we really want you to be able to understand the credits, the debits from your water account as a landowner, as a user in a groundwater basin. And to be clear, the platform does not support trading at this point. So really is a visualization tool for GSAs developing their own policies for landowners to be able to visualize those policies, work within their allocation to better manage their budgets like you would in a checking account. And I see that we answered the question about customizable water supply types. So thanks so much for covering that and flagging that your question got answered. Similar to that, we saw a question about native yield rainwater or well water, and can the tool use all three of those sources? And maybe Andy, I'll let you flag what you used in your presentation.
Yeah, so I'll share my screen here real quick. When we configure water use types, water supply types, we can do it here from our geography configuration page. And these are simply arbitrary things that we set up. And so we can name them whatever we want, we can call them whatever we want, and then we can apply data values to those. And so we can use as many or as few as we want. We're going to be building in features in the future that allow us to determine in what order that supply types are used in. So that feature functionality is to come.
Thanks, Andy. And then we also, I see you kind of revoked your question, Gus, but we do support calendar years and water years. Is that right, Andy?
Yeah, that is another one of the configurations we have.
Yeah.
You can actually configure when your water year starts. So it's never just like October 1st, but you can say my water year starts February 1st, and you can call it whatever you want. You can say it's my fiscal year. And so the platform is meant to be scalable, but also configurable. And so we can name these things, the things that make sense for our base.
Perfect. And then we have a question here about requesting changes to parcels connected to your account. So is there a feature in the user account or the landowner dashboard for requesting a change to your parcel that's connected to account, i.e. additions, subtractions of leased parcels?
If we were having this demo 6 weeks from now, yes, that would be a thing. That's under the current contract. We're building that particular feature. Yes, that's kind of thing.
Sweet. And then we have a question about merging accounts, and do they have to be in the same zone?
I believe so. I believe that's the logic we built into the platform. Zones are going to be so important for allocations and allocation plans. And so merging accounts that have that have parcels that have two different allocation plans applied to them wouldn't necessarily work. So yes, you have to both be in the same zone to validate and work.
Cool. And then we have a question here about data flagging. So someone asks if data is flagged in the water account budget to an overarching accounting platform personnel, so not a GSA or a landowner, if say the basin is over allocated or shows signs of overdraft, with the goal of really helping to assist with sustainability. So we as platform administrators are not managing the accounts. That is really like the GSA's responsibility. And so the GSA might hire staff to do that management. They might work with consultants to do that management. And we're obviously there for support, but the long-term vision is that the administrators of these water accounts would really be based in the GSA, and that would be the overarching reporting structure for landowners. Andy, is there anything I'm missing there that you wanted to add?
I would say that alerts and tools that help identify accounts that are, overdrafted are part of the roadmap of the platform. And so at the moment, there's nothing in there that's flagging, but that is certainly something we want to build in the platform.
Definitely. Yeah. And I think that kind of gets at Patty's next question, where if changes are made, is the landowner notified? And if the landowner makes changes, is the water district notified of those changes? And if there's over usage amounts, who gets notified? And so that's all kind of part of the next phase of build out, is building in this kind of report out or outputs, but then also kind of a flagging system for landowners to interact with, and for GSAs to manage those flags from landowners. Mark all of these as done. Going through. Thanks everyone for so much activity. And then we have a question about associated fees. Is it per user license fee, or is it an organizational license? And so this is a great question. We've sort of structured it so that it's open source, but that doesn't mean it's free. I've heard the analogy that that's kind of free like a puppy, which I think is great. But it really is based on the policies, the complexities, the needs of a GSA or a water district. And so we are working with GSAs directly to kind of set fees appropriate for their needs, for their staffing levels. So there's sort of like a keep the lights on fee and an onboarding fee for the first year. And then based on the needs of the GSA, that there might be more or less that they would like to add on. Andy, I know ESA has kind of been working through that. So is there anything you want to add there?
About the fee structure?
Yeah, that I missed. I don't know.
No, I don't think so. I mean, I guess I would also mention that there is always the opportunity for custom application development. If there are features that you desperately need for your GSA, that we're more than happy to work with water managers to build exactly what they need in the platform.
And I would say that has kind of been, thanks for flagging that, Andy. That has been kind of, we've seen that already. Like certain pilot partners have needed certain features or certain tools to come online faster than our other pilot partners. And so while we were kind of in the pilot phase, it made sense for them to fund those customized features independently to get them spun up quickly. But we've done the work to make sure that the architecture is pretty seamless. And so any tools that are developed can be integrated back into the platform. So the well registration is a great example of that, where Andy and his team did a great job at ESA, kind of building that out quickly for Miagusa, but it's now being integrated in the platform for the benefit of all the other users. Going through here. Relative. Thanks so much. You're all coming in so quickly.
Hannah, it looks like I could jump on the next two.
Oh yeah, please. Thanks.
There's a question about GET and what it assumes for where you're adding a well. Does it assume a fully screened well? And it can, but it can also we can set it up so that it specifies the pumping in a specific layer, and we can also set it up so that it puts the pumping in to multiple layers at predefined proportions. So there's quite a bit of flexibility there. And then the question on relative transmissivity in the model comes from existing models. Absolutely, that is the key and the beauty behind GET is we're taking a groundwater model that an agency put a lot of blood, sweat, and tears into to develop and make useful and accurate, and making it available through the platform to do these simple scenarios. So it is literally running the groundwater model. It's not making any guesses at what the model would think or anything like that.
Thanks for that, Jim. I'm also seeing a question about availability for this platform on mobile devices and maybe tablets. So it should be available on your mobile device. I don't think we actually have an app for it yet, but you can navigate it to on your browser on your mobile device, and we've made sure that it's mobile friendly and tablet friendly, and we're continuing to kind of iterate on that to make sure that the functionality works for all people who want to access it on different devices. Is there anything there I'm missing, Andy? I think it's kind of
the site is built responsibly to meet all form factors.
Yeah. And then I'm getting a question about this seems geared towards individual landowners. Does the system have functionality for wells operated by local water suppliers? And then the fact that water suppliers serve hundreds of parcels that they do not own. And yes, we work a lot with the GSAs and districts directly. And that's kind of the water manager dashboard that Andy walked through. So they manage many parcels that they don't own through that manager dashboard to kind of track towards allocation. And really, it's not just for basins and overdraft. It is for anyone who wants to do accounting. So GSAs who want to manage their groundwater transparently with their landowners can use this tool and showcase, how they're tracking those resources and allocations, things like that. Is there anything I'm missing there, Noah, Andy, Jim, that you would add? Cool. How does groundwater model calibration, maybe this is for you, Jim, information get shared with the user? Seems like this would be important to share with the user. The model output does not show the possible pluses or minuses of predicted water levels.
Sure, a great question. And I think this is really where the role for groundwater modelers is still there. They understand the models they developed and the relative certainty involved in those models, and that can vary over space and time. And we can take that knowledge that they have about relative uncertainties and insert that information into the output that we're providing. We can also just link to model documentation, other external websites or anything like that might be useful to have quick access to outside of the system.
That's great, Jim. And I think a really good follow-up question about any safeguards prevent users from placing wells maybe too close to a boundary condition that might produce unrealistic results, like near a constant head boundary or something like that. And then asking about any flags that might be displayed for something like that.
Yeah, that's a great question too. And we showed the model boundary when I was demoing the page, and that is actually the boundary of that model, which is pushed out away from the edges of Merced County or the Merced subbasin. But we can limit where a user is allowed to put a well. So if we didn't want that boundary area to be usable as a place where a well could be, we could change the way that the model input is or the model area is shown. And of course, you can't put a model outside of the model area. So yeah, we can try to limit those things. And we can also, I guess goes to, again, to my comment about more actionable intelligence, because one area, the problem could be water level declines. In another area, you might be near streams where groundwater surface water interaction is what's important. And groundwater level declines don't really factor in. So we can change, we can customize the information that you're getting by model as well.
Yeah, and then I think another follow-up there, Jim, is just a question about who maintains and updates these models with new water level information, new wells, once it's online in the platform. And so we use two different models in the platform, IWFM and ModFlow. But Jim, maybe you can speak a bit more to how it's updated.
Yeah, I mean, again, this is the role for the groundwater modelers. They
Yeah.
need to continue to make improvements to the models and update them so that they're current. And anytime a model is improved or updated, we can simply slide those files into the system and if needed, segregate that from any previous runs that wouldn't be comparable.
Great. Thanks, Jim. And then we have a question about, can we have more than one account in each APR? And then can the size of the leased land be scalable or changeable? And so, yes, we can definitely have, we've structured the data or the visualization in the platform so that landowners who own parcels in different areas or different districts, different GSAs, ideally can log in to the platform under one user account and be able to manage each of those accounts, each of these parcels. And so the GSAs or the district might have separate policies managing those parcels, but from the landowner perspective, it would be a unified experience. So you're not logging into 5 different dashboards to try and manage the land that you own. I hope that answered your question, but maybe Andy, if there was anything you wanted to add there.
I think that's a good answer. The platform has multiple tenants, and a landowner user can belong to multiple of those tenants. We have Miagusa and Merced Subbasin GSA who are next door neighbors, and landowners or growers who have land in both of those GSAs will have a seamless transition between both those places in the platform.
Cool. Yeah, and then we have a final question about native yield. Is that equal to effective precipitation? And so, working with all of our GSA, we've really found that effective precipitation is really going to be a local question in some ways, a local policy question. So each of our data sources, Land IQ, we can accommodate, OpenET, we can accommodate. Some districts use metering data. So the different data sources have ways to accommodate effective precip, obviously, but it's going to be up to the GSAs to kind of set the policy of what that rate is and how they would like that calculated to be represented into the platform. So I hope that answered your question, Willie. Well, I know we're almost at time. I'm not sure if there's any lingering questions or any items that we should go over. Thank you all so much for being so engaged in the Q&A. This was awesome.
Yeah, thanks for everyone for taking time today.
Perfect. And then one last question. Yes, the recording will be available on our YouTube. We just put the link in the chat. And then also a question about meter data. So that is going to be a policy determined by the GSA or district, how they would like meter data to be used, maybe alongside of evapotranspiration data or in lieu of. But if you have any further questions on that, please feel free to email us and we can help talk through it. Thanks so much, everyone, for tuning in. Cool. I think with that, we'll round out the presentation. Thanks for joining us. Please go to that YouTube if you would like to see the recording. We'll also make sure to post the slides online. I saw a question about that. You'll be able to find that on the consortium's website, which I believe Noah shared on the screen. It's cawaterdata.org. But thank you all so much for joining again today. Bye, everyone.
Bye.